It always takes just a second for YouTube to catch up. All right, so we're good. So welcome everybody.
It always takes just a second for YouTube to catch up.
Okay. Okay, so now we have it. So welcome everybody to the Drill Bit Industry Technical Steering Committee. We've got a great audience in store here today. So I am going to introduce Andrew Poor with Smiths / Schlumberger. He's going to be our chairperson today, and he can introduce the rest of the panel as we go ahead. So Andrew, it's all yours. Everybody can see the screen.
Talking into a muted microphone doesn't work very well, apparently. So, first of all, thank you, Jim, and everybody else for participating, giving me the opportunity to hold this discussion and bring these topics up. I think hopefully we'll have some good conversations out of this. Firstly, I'll just go down the list as I see them here. I'll be co-chairing here with Matt Bose from Halliburton. So appreciate his involvement as well. So Brandon Linford from US Synthetic is here. Dustin Dashel with Shell. Of course, Jim Oberkircher has kind of been handling all of the technical details and things like that surrounding this. And the infamous Paul Pastusik is also present here and probably willing to share his thoughts too. So there's a few more as well, committee members that will be hopefully joining us as it progresses. Had some prior commitments, so they couldn't join right now. But with that, I'll leave it whenever they join up. I'll give them the introduction they deserve. So I wanted to really start this committee out by posing a question that will help frame out, hopefully, what it is we're talking about and why we're talking about it. So what's the objective of, we're going to talk specifically about, bit designs and implications on directional profiles and things like that. But what's the objective of doing, so many bit designs, having motor options, doing all the development? What did the operators want from the optimizing BHAs and optimizing bits and, combining these two optimizations to have a full optimized drilling system? I wanted to pose that question out there and getting some creative juices flowing. Why are we doing all this stuff? So I'll maybe start with Paul, and we can go from there.
Well, it's for me, it's a real easy thing, and that is I want all my drill bits to drill at rig limit ROP and drill the entire section in one run. If I have to make a trip for the drill bit or the BHA, I'm wasting time and money. So, and I want the wellbore to be no excessive kinks or any, the best wellbore quality that I can get. I would say this about wellbore quality, and that is just getting the casing down. I also have to be able to get other tools down. I need to make sure that if I'm logging it, that I don't superimpose a borehole pattern on top of logging information, trying to look through wavy glass and all that. So, I'd like to, if I do know that a gauge hole I can keep clean. So, all of my hole cleaning issues on high angle holes come from oversize. So it needs to be in gauge, smooth as possible, no excessive dogleg severity. I want to drill at rig limit ROP, and I don't want to be constrained by having to make any extra trips. So how's that?
That's it. So we're looking for it. Dustin, I'll just kind of lead off with the operators in this case and let Dustin and
Sure.
share.
Yeah, I mean, I'll hit on some of the exact same themes. At the very top level, the main reason for doing any type of optimization work is to reduce the overall cost. And that's of course going to, accompany many things. So reducing unit development costs. And so that, that's going to mean drilling the section as quick as possible, running the casing as quick as possible, and handing the well over to your next customer, whether it's completions or production, in a state that is in the best possible condition for them. So like Paul, we're trying to move the drill bit out of the way as a limiter for performance. Although I have to say in a lot of applications in the shale business, the drill bit still is the limiter. This may not be so in the Gulf of Mexico or Gulf of Thailand, Malaysia, etc., where you could basically put a 3-blade in there and drill at 1,000 foot an hour with 5,000 pounds. But so that's the main goal, especially in the shale business where margins are relatively thin to begin with. We're consistently benchmarked against our peers. There really is no excuse for falling behind. We're continuously trying to reduce days, which is going to reduce cost. And the same thing goes for in motor performance. I don't know if you wanted to talk about that right now, but in general, on the motor side of things, we're trying to input the maximum amount of horsepower to the drill bit without prematurely damaging the drill bit, so that we can maximize penetration. And as bit technology evolves, so does our available input horsepower without taking that damage to the cutting structure. So those two kind of move in lockstep. Certainly with the big improvements in thermal stability of cutters over the last few years, we've been able to make some pretty large incremental improvements in input horsepower. I would say overall right now, probably the motor is at a couple steps above what the drill bit can put out in terms of bit torque. So that continues to evolve.
Sure, you touched on an interesting topic there, is the drill bit as being the limiter. If you could expand on that, and I'm going to maybe pull Brandon in here in a little bit to talk about that as well. So, what is it about the drill bit? I mean, you say in terms of maybe torque response, in terms of what else is, say, limiting the performance? I guess.
Okay, well, let me just speak towards the shales for a little bit here in North America, because I think a lot of people are kind of heavily involved in that. Generally, we're talking slim hole, or 8.5 or smaller in terms of main hole performance. So hole cleaning is not generally the major limitation there. And generally, the motors these days, whether you're talking 7 1/4 or 5 3/4 motors, or 9-inch, 9 5/8 above. Power section manufacturers and lower end manufacturers have come to the point where, that they have relatively decent amount of overhead capacity compared to the bit torques they're generating. So really, what we're often limited by is braking cutters. That just is the predominant mechanism that I see in the industry right now, is tangential overloads, snapping the cutters right off the stud, and then quickly having that snowball into a flow bone core out, or in some cases a ring out, but oftentimes a core out, sometimes nose damage. And if we were able to input more axial force, more weight on bit, we would generate more torque. But we can't, because we're trying to complete the run in a single section without breaking the thing. So in that respect, it's the limiter often.
Okay. Brandon, thoughts?
Yeah, I mean, this is a complicated problem because the cutter and the bit is so just alone in that system is so interdependent on how we lay out the cutters, what the back rake, side rakes are going to be, cutter diameter, cutter density, chamfer angle. And it's almost infinite the number of factors you can put into just thinking about the bit design and the cutter design itself. And so, our approach generally is to work directly with a bit customer to customize our product to work with them together as a system, and to go through that process iteratively. So we'll develop a new cutter, test it, see the failures, bring it back to the lab, and keep on improving that way. But one thing I'll bring up with what Dustin said with the energy put into the bit is, as we change those parameters, as we increase the horsepower that's going to the bit and the energy going to that, it changes the failure mode that holds the cutter back. So I'd say a few years ago, the primary focus at US Synthetic and multiple cutter vendors was abrasion. With the torque and weight we had at that time, cutters were wearing out, and so we worked on improving the abrasion of it. Now we're seeing a lot more of what Dustin said, thermal failures. As we put more energy into the cutter, it's going to heat up faster and fail faster in thermal, and also mechanical fractures. And so that changes not only on our trade-off curves, how we're going to design the product, but also changes what our R&D teams need to do to develop new technologies to overcome those failures. And so we really view this chain of the operators maximizing performance of the well, the bit company maximizing the design of the bit, and the cutter company trying to catch up there as well, all have to be tied together. And the better we can do that together, the faster we can achieve the performance gains.
Yeah, no, thank you for those thoughts, Brandon. I think that's just spot on. And Dustin, you touched on something else here. I'll kind of go to the third point of a commercial win-win, right? So as everybody's seemingly working themselves out of a job, right? As you get fewer bit runs, you get fewer revenues, and if you're drilling faster, say a day rate for a motor goes down, right? Your revenue on that motor goes down. And so I think having the commercial win-win is a really important aspect of doing this as a team. How do we get there? Brandon hit it. It's a collaborative effort. If one party is suffering, I guess, financially, and the other one's gaining, it tends to not work out well overall, right? So just to kind of throw it out there in terms of a commercial win-win for everybody, I think it's possible. And I'm not thinking ideal world scenario, right? There's a lot of market dynamics and things that go into that, but I think any other thoughts from Matt or anybody else that's joined on kind of what's the objective? Why are we doing all this stuff? Why are we collaborating? And that's really the question we're posing here, and we went into some detail about it, but I'm curious anybody else's thoughts.
Well, I'll just say this simply: if we don't collaborate, somebody else will.
Yeah.
Like that's the nature of the beast, And then their unit development cost becomes lower. Their break-even cost for price of barrel costs lower. Their market share increases, ours decreases. Like it's pretty much that simple. Survival of the fittest.
Yeah, I will reinforce that too. It's an interesting thing. If you're on the receiving end, you may think that, an operator, we just want the lowest possible price ever. And yes, we do want the lowest price, but we don't want anybody to go out of business, right? I mean, you guys have to build things for us and you have to be able to make a profit in the long term. And and one of the things about collaboration is, I'm going to tell what I believe to be the case, and that is, if you add up the number of pounds of tungsten carbide matrix and the number of cutters and you add it all up and everything else, the difference in cost in a bit that works and one that does not is negligible. So the cost is the same. The key thing is to get one that works, and that is collaboration. So, Dustin said something about, you're talking about the cutter fracture being a big deal. Man, I am all over that one too. That tangential overload is, in fact, our number one mode of failure in most cases. And we even know kind of how that occurs. I mean, what to do about it and all that. It is a collaborative effort, because I want to say this is true for cutters, for drill bits, for motors. I want to treat them as a tractor. Okay. You tell me that a tractor is rated for 100 horsepower. I want to be able to get 100 horsepower out of it. You tell me a motor will drill with, 1500 PSI differential. That's what I want to get out of it. When it comes to cutters, if you tell me it'll drill a 40,000 PSI rock at 0.2 inch per revolution, that's what I want to be able to do. So that's the kind of rating that I want, which is what can you do day in, day out, continuously without absolute catastrophic failure. And then we'll do everything we can to stay within that because it is in our interest. I mean, if you think that we like making trips, trust me, that is not the case. It's you may not like it. You sure don't like DBRs. We don't either. So.
Can you guys hear me?
Yes, sir.
I'll just kind of add to that, right? And collaborate sounds like an easy word sometimes, but it's a lot more difficult than just that. There's a lot of moving parts and pieces within the service companies and the operators, right? And it's getting everybody on board to go try something. We have a lot of great ideas and we talk a lot sometimes, but unless we fully execute it all the way through, it doesn't really matter, right? It's just a lot of wasted time. So the collaboration piece is important, but it's a much more difficult word than what it sounds like sometimes. There's a lot of moving pieces.
Absolutely, it is. Often the case, maybe a bit company will talk to an operator, and a directional company will talk to an operator, and a cutter company will talk to an operator. But then it's got to flow around, right? It's got to flow around in order to be the most effective. And often maybe it doesn't as often as it should. And the more it happens, to Paul and Dustin and Brandon and Matt's point, that's what it's going to take, and it's got to be a concerted effort from everybody to kind of hold everybody else accountable. So I think it's a very interesting prospect to get everybody on board with this idea and to really live it, right, and to embody it, to get the most benefit out of it. So unless there's any other comments, I think we've framed out what the intent behind this is, right, is to get everybody on board with collaborating, right, to in essence achieve the end goal of who we're serving, right, is kind of as the operators trying to deliver their product to market, and how do they get there faster and more efficiently? How does everybody contribute to that end goal? So with that, I think when IADD over the last couple of weeks has been going down a road of digital transformation, and I feel like this first kind of segue is first discussion is a nice segue into that from the digital transformation into bits, right, into what is regarded in, say, the bits world as important. So the role of digital, particularly in downhole sensors and in drilling performance. And I know Dustin and Paul have weighed in on this before in terms of downhole sensors and digital components, generally speaking. That's been covered in previous topics, but I want to dig into this a little bit more because it is transformational, right, to this industry when you can effectively leverage the information. It's extremely powerful, right, and especially in the density that it is. So first question right out of the gate is, what's the value and what are we looking for out of these digital things, right? Particularly downhole sensors. I'll focus it in on that. What is the value? Is there an inherent value? It's hard to put a dollar amount on a value of, say, data, but what is it from Dustin and Paul's perspective, from an operator perspective? What is the value of this information?
Okay, well, I mean, I can give you my perspective on downhole instrumentation and where I see the value case. To me, it really revolves around two types of buckets. One is real-time decision making. So we see that there's a particular vibration, excitation, mode, and we address that, whether it's axial bounce, lateral vibration, or perhaps even stick slip. And then the other, of course, is identifying post-mortem what the problem is and working around that problem, redesigning or limiter redesign, if I can throw that trademark statement out there, so that we don't have the same failure mechanism again. There are probably other scenarios, that I'm forgetting about, but I believe the vast majority of the value is derived from those two types of circumstances. And, if the data just gets filed away as a PDF in your Outlook and it's not actioned in any way, shape, or form, I'm going to tell you, like, that service is probably not going to be sustainable. People are probably not going to want to continue to pay for it. And you're not going to be able to continue to monetize the money that you put into developing that sensor platform. So I think one of the big problems right now with the services that are out there is the product that is delivered is not interactive. There are some exceptions to that with some very basic, interactive tools, but I think we really need to see, if you want to get more penetration and more action from the data, you have to make it interactive.
Yeah, I'm going to add a couple of things. I'm going to basically agree. It's surprising. I don't think that's going to be too much surprise that Dustin and I agree on many things. But a couple of things I always talk about, who wins in the marketplace. Usually who wins is whoever can do the fastest, I'll call it cycle time. Design, build, test, get the data back and analyze and make the next improvement. If you can do 4 cycles a year, you're way ahead of the guy that can do 2 or 3. And no matter where you start technology wise, if you can run those cycles faster, you're going to win. Now, I'm going to say that's given one other thing. That's the effectiveness of that design change. I have seen people that stir the pot. It's like, oh, test one of these. Oh, I just added some magic dust. Try this. Don't work too well. I don't really care for them. We spend a lot of time with you guys monitoring test pieces and things like that. And so they need to be well thought out trials. I think the data that you get from a downhole module adds dramatically to the quality or the effectiveness of those trials. So, you had a bad run. Would you find out that, oh man, I drilled out on site, in the shoe and this thing was rattling around like crazy, and you go, the bad run had nothing to do with the trial that I planned or something. Or vice versa, you see that you just did a new bit design that is inherently more stable in that little zone that I was looking at, that's the difficult to drill section or whatever. So I think the downhole tools can improve the effectiveness of each design cycle tremendously. In fact, I've seen that. Real time, getting that data real time. It's interesting in the big wells, the offshore stuff where I'm only going to drill a few wells. I need data real time because I'm not going to drill enough wells to learn fast enough. In a land-based operation, unconventionals. Yeah. Oh yeah. And I can afford some money there. Usually, I don't like to spend it. By the way, don't want to tell you got a free reign, but I might be willing to spend $5,000 on a module. In a land US operation, and you add $5,000 to my cost, I'm going, man, I don't know. I'm really looking at cost. Now, if you show me that it can reduce my cycle count or that it can reduce my trips, that's really good, right? So it is interesting. I have taught a lot of vendors that are looking at data what I want to see, and I would say, we have an interesting thing. It's like I want a base frame data that looks like the depth-based, time-based. These are the plots that I want to see based on your sensors that you have. And I want to see that every time. And then I'm with Dustin. Then I want everything in an easy to explore, so I can play with the data, as I call it. But I want to be able to look around and play, because I don't know everything that I'm looking for. I look at the data and see something interesting and say, go in, and I want to zoom in on that little piece. So give me a standard format that you probably have to work with each operator to get. I happen to know mine's the best because it's what I like, but but the reality is, I'm sure other people have better ideas on other things too. So anyway, a series of standard formats is probably what you need, and then the ability to explore is the way I would look at it.
So if I could summarize both of y'all's comments, I think capturing learnings effectively would that be kind of in line with what you guys are saying, right? Play with the data, capture the learnings, implement the learnings, save money, basically, right? That's save money and time.
Yeah, it is. I mean, it should just be built into your design cycle, your design, test, build cycle, right, that you do. And again, if you can do it cheap enough, and I've got some vendors that have basically said, we're willing to put modules in our drill bits all the time because we learn faster. Well, guess what? They're going to win products. They're going to win revenues from us if it's effective. If it's not effective, they took a risk, so to speak, that it's going to help them. And of course, I'm going to do absolutely everything I can to make sure that we get the best out of the data and they get the best out of it too. So.
Okay. Brandon, any thoughts here? Matt?
Yeah, I have a couple thoughts. One, anytime we improve our ability to see, we're going to learn faster. We see this internally at Synthetic. Every time we develop a new lab test, we see a remarkable increase in our rate of learning. Anytime we can see better data from the field, we learn faster. So I think inherently, whether that is ways we collect the data post-mortem and analyze it and use it into our build cycle, or we can see those things faster, it helps us. One idea I want to put out there, and I know this is more difficult to actually achieve. Dustin brought up the active monitoring. Many times we are being asked to solve drilling dysfunction problems with a cutter, and the cutter doesn't solve the drilling dysfunction, but we're trying to overcome it through material science. And we've done a lot of hard things and made a lot of improvement in material properties, but it is hard to overcome drilling dysfunction with changing material properties on a cutter. And so I think if in a future state world, if we had ability to actively monitor and change drilling parameters as we're drilling, not only will it prevent some damage to the cutting structure, but it'll enable us to push the design limits even further, because we have to give a lot of trade-offs to try and survive these impact events. That's my 2 cents on the sensors.
Yeah, I'm going to add something too. And I think maybe because your vendor is the drill bit manufacturer and not the operator, I think we've left you guys out of the loop too often and too far. And when we share data, it ought to go all the way down through the chain of command of everybody that's contributing significant elements. So, I certainly believe cutter vendors ought to be in that discussion when we're talking about performance reviews. Sometimes vendors don't want to tell us whose cutters they're buying and all that stuff. Okay, man, I probably know that anyway, but so I don't think it's probably as sensitive as they may think. But the reality is, you guys have a big interest in improving things too, and I think we'd be better off sharing that rather than trying to hold it secret somehow.
Completely agree. I just want to reiterate something that Paul said that I just think is hopefully it didn't get lost. And he mentioned that instrumentation while doing trials is so impactful. And I just wanted to double up on that, because the amount of times I can say that we have written a product off due to a bad trial, and then subsequently years later come back to it to find that it actually was the solution, and there was some conflicting or conflating variable during the test which rendered it either a no test or a negative test, when if we would have had the instrumentation at the time, we would have known that actually this variable out here was causing, this undesirable outcome. We probably could have saved ourselves hundreds of thousands, if not millions, by jumping into that solution earlier. And if you're flying blind and you're only relying on, let's say, a drill bit dull at the end of the run, your inference might not be as accurate as you think it is. And this could be just for like cutter shape, cutter type. I mean, it's just the variables are endless, and the stuff that you could write off, it could be really detrimental based on a single data point, which we know we do all the time in this industry. Oh, that only drilled 300 feet. Oh, why? Yeah, we've blown up in this shoe. No. It's the new cutter. I swear. This is pervasive. So yeah.
That's the only thing I changed is the new cutter. And oh, by the way, I did a different motor and I got different mud, and it is a new shoe track that I drilled out, and on and on. Yeah.
So and it's an interesting, right? We're kind of going into the role of what an operator should be doing and what a service company should be doing. So I'll let the conversation continue from here, but really, the role of operators, Paul, I guess you sound like you're of the mindset that the service companies design the sensor and take the risk of investing in the sensor and saying, hey, if I improve my cycle time, I will win with the customer and I'll increase my market share and I will therefore increase my revenue. Is there any contradicting thought to that?
I can certainly imagine there being some pushback saying, well, what, don't you get any other value from a sensor like that? And the answer is yes. Certainly, so what else does the operator get out of us? Just MWD sensors. If you look at, we get borehole quality information. We get, with LWD, we get formation valuation data that's really important. But somebody wrote in on the chat, they did a question about where do HFTOs come from, and I just gave them, I have a presentation on deal, and I just loaded them up with about 20 or 30 references on that subject. But as an example, HFTO appears to be driven by high hard rock, hard brittle rock drilling, which excites the cutting mechanism. So if I have a sensor in the bit that can tell me where the HFTO segments are within the drilling, that's formation information. That's not just about the drill bit. So there is additional value in being able to process that and show me that HFTOs are occurring or not. By the way, my sensors have to be, on the order of sampling at 1,000 hertz, and you may or may not have enough time to do all that. But Dustin tells me HFTO message just went to the panelists. Oops, I'll fix that. I'll give it out to everybody, but in a minute. There is additional value from those sensors, whether they be Inbit or not. But the first and foremost one for me is if it'll help drive the design cycle faster and more effectively, that's probably its first and foremost role.
Gotcha. So basically the most benefit is for the service companies that have the sensor.
That's what I think.
Okay.
Yeah, I think I would agree with that. And I'm not sure whether you wanted to go down this rabbit hole or not, but I will say that I have an extreme soft spot for in-bit force measurements. I think the data you can glean from that is significantly more impactful than accelerations alone. And that's going to be, that's actually going to drive some procurement decisions in some places, having that available.
Okay. So in terms of, implementing the learnings, the information that say the service company is going to get out in the sensors is going to basically drive a better product, which is going to drive your performance better, right? This is the cycle, right? And then new products get new data, which lends itself to new products and new data, right? So, okay, no, that's fantastic. So Dustin, you touched on this earlier, I'll slip you the backdoor check here. for plugging it. But who's stronger, bits or motors? I think this topic is hopefully a controversial one and gets people to seriously, consider what's out there. And so, I'll kind of let who wants to speak first about bits or motors being more robust or more capabilities, right?
I'll just.
Yeah, I just had a couple
of
questions.
Andrew. Go ahead, Andrew. Okay, well, I don't even think it's a question for U.S. land market. Motors are stronger. Kudos to how efficient the shale business has become in North America land, and the absolute relentless nature of both the power section manufacturers and the lower end designers and directional companies. These things are beasts. Like we go entire rig line years without a motor failure now in the shale business, pushing weight on bit and bit torques double or triple what they were 5 years ago. It's no wonder, investor deck after investor deck from the shale companies keep showing incremental improvement in days and cost, because we just keep throwing more and more energy at everything. And the motors are not breaking. If your motors are breaking, I suggest you either work with your vendor to not break them or find a different one, because this is largely a thing of the past. Also, outside maybe like perhaps the ultra high, the high temperature stuff in Haynesville, et cetera, or if you're doing extremely long runs in South Texas, curved lateral, that's a slightly different prospect. But any of the West Texas Permian stuff, motor failures are gone.
I wish that was the case for us too. That's not quite true, but I think we know some of the things that we're doing to cause our own failures, so we can get to that. But.
So more power is always better, Dustin. More power is always better.
Yeah, more input power is going to be more ROP. And of course, you want the equipment to be able to take that input power and then have some overhead above that.
Okay. Matt, maybe you can weigh in on this, and Brandon is.
I don't know that there's really much more to weigh in on it. It kind of is what it is. I don't know if you throw the MWD into the equation, does that change some things a little bit? That seems to be a big reason why things are pulled too. But yeah, you've got a tremendous amount of different applications across U.S. land. But all in all, I agree with Dustin's comments on it.
Yeah, and to kind of to temper it with Paul's, we know what causes our own problem, and the reason why I think it prompted me with this question was specifically in the Bakken was they had put some 10+ stage motors in their laterals, and it just shook everything else apart. And so my question was, is more power always better if it's a detriment to, and again, this is in relation to bits, but in the kind of the drilling, in the context of the drilling system and what we're trying to achieve, right, is less bit runs and all these things, less BHA runs, I guess, too. So
I will kind of add, maybe before we get into that too, I'm not sidestepping the question, but there is a tremendous amount of work still being done on advancing, right, from a connection standpoint, from a cutter standpoint, from a material. Those things are not going away. Those are still full force ahead. So I didn't want to act like the question was sidestepped.
Yeah, I'm gonna say a couple of things. Yeah, more power, more torque is more ROP, bottom line. And I have had people say, "Oh, I don't need all that ROP." Well, great. If you want to stay out of the fence, go ahead. But I have had people say, "Oh, well, ROP causes hole quality problems." No, in fact, the faster I drill it, the less time I'm in the hole, the less collapse I get, the less vibration that I get, as long as I can handle the stick slip, certainly the less lateral vibration, the higher depth of cut. So basically, there's no downside to drilling a hole faster that I know of it. You just go and tell me what it may be. Hole cleaning, as long as I can keep the hole clean, and if it's engaged, by the way, I can always keep it clean. My whole cleaning problems show up when I start letting it rattle around and getting oversized and making extra trips. So the one of the questions you asked there that I'd like to answer specifically, which is, are there bit features that can help you, in terms of compatibility with motors? And the answer, yeah, depth of cut elements. Without a doubt, I can control the aggressiveness. I can, unlike power, I can make, more power is better as long as I can use it. Okay. There's no reason to put, 5 stages on a motor if I only need 4 or something like that. But if I can, as long as I can use it, I want the power. Depth of cut elements we use to control the aggressiveness of the drill bit. I can make a PDC bit way, way too aggressive, really grabby, stick, back off connections, cause all kinds of problems. And we use those guys to control the aggressiveness. So that is for me, and way better than changing the back rakes. It's way better than big chamfers because I can control when it comes into play, what penetration per revolution, and I can control how much contact area it is. So kind of how I modify the aggressiveness, and we use them. In fact, I don't even know. Yeah, I guess there's a few bits I've seen without them, but it's like a 98% of the time we've got some kind of a depth of cut element engaged at a certain very well-designed specific kind of a thing. So for me, that's the number one thing you can do for compatibility with motors and RSS tools, by the way, and cutter life, by the way, Brandon. So your cutters hold up to a certain depth of cut, all right, well, let's design that depth of cut into those DOC elements so that we don't exceed your structural limits. I can do that. Well, the big guys can do it, but I can talk to them about it.
Then hopefully they don't wear the depth of cut control.
Oh yeah, boy, I just fussed at somebody just this morning about giving me some that were worn out, and they were making design changes and didn't address that issue. And I'm going, why didn't you bring that up in your design review? That's a critical element. It's got to be intact throughout the life of the run. Yeah, good point.
So Brandon, I'll let you if you've got some comments.
Yeah, so I think it's touching on a couple earlier themes, but as we put more energy into the bit, it changes the failure mode of the cutter, and it also changes the trade-off choices we make when we're designing a product. So when we literally have dozens of choices we can make when we're designing the cutter, we're making a complex composite material with lots of stress. We're pressing these things at over 1 million PSI, and there's a lot of material science that goes into that. And we have I'd say that we kind of have based on our history, we have a set of understandings of what works well and what doesn't work well. But my sense is as the energy input has increased, those factors are changing, and we need to change our mindset and our tests to match that. And so I go back to that collaboration piece of how do we connect those things together. We value stream map out our development cycles. We know how long it takes. Like any process, the value added piece of that is less than the weighting and the logistics and all that. So you just walk through the time it takes to develop a cutter and then to put that cutter in a bit and test it and then make a decision if that was a better or worse choice. We're talking months and months and months. It doesn't have to be that way. And in many cases with a bit company, we've demonstrated faster ability, but usually that's through expediting and things like that. So I think there's a lot of process improvement as well that's available to help improve this system of learning fast, seeing the problem, adjusting the cutter design and the bit design, and then looking at the outcome and deciding if that was a good choice or not. So we just see a lot of potential there. And we've worked with our great customers too to do that in certain circumstances as well, to do it faster. Over years, we've gotten faster, but I think there's just so much more opportunity there to get faster.
So question to Brandon on this: how are 3D shapes influencing this? We're talking mostly, I think, about 2D cutters, right? And how is the onset of the 3D cutter innovation space changed this concept of bit torque and where the torque is generated and how those depth of cuts and how the ridges form and how the ridges look and interact with each other, right? So I think that's a very interesting topic to cover. I just want to get your thoughts on that.
Yeah, I mean, I think the 3D shapes is a hot topic in the industry. There's certainly a lot of research is being done into shapes. A few years ago, when we started seeing this trend, we had to decide at US Synthetic how we were going to approach this. Historically, we've made a 3D shaped cutter. We've been making shapes for decades, but they haven't taken off. And historically, if you wanted to shape diamond, you had to choose some significant trade-offs to make that shape. And you wouldn't maintain the same thermal or abrasive properties with that new shape. And so at US Synthetic, we decided first to invest in developing manufacturing processes and technologies that enable us to take any cutter with the best diamond properties and turn it to any shape. And that has been an enabler. So a lot of our bit customers have invested their own R&D dollars into developing their own shapes and then using our technology on manufacturing to take the best diamond product that we sell to them and turn it into that shape. And that's where we've seen a lot of gains. We certainly we've seen trends in better drilling efficiency. I think an area that needs to be explored more is how we can improve bit stability. As we go through that, we certainly see less torque needed to break the rock, which is always good for cutter life. But you know, I'd say generally the bit companies have become more experts in what actual shape to use, and we've become more expert in how to turn that shape into a reality with the best diamond properties.
Okay. Very good. I'll pause here and ask Jim if there's any questions from our audience on some of the stuff that we've covered.
Yeah, it's along the line. Sucor has a question: basic idea between vertical well bit profile and directional well bit profile. So what's the difference? I think is what he's asking there.
Who wants to take this one? Does Matt want to take this one? Or Dustin? Maybe?
Is he asking on the bit profile itself, or?
I think they're saying well profile, I think.
Well, like how does well profile impact, you know, drill bit design selection criteria? Is that kind of fair? Where is this question?
I guess maybe the question, if I'm going to try to
on the bottom of the screen, Dustin, if you see Q&A, it all.
Okay. Okay.
Is there a difference? Yeah. Vertical well bit okay, so is there a difference between the bit profile in a vertical application or a directional application?
I mean, I think that depends a lot on the drive mechanism, you know, whether, you know, you're using galvanized lead motors or rotary steerable, and, you know, how important or how difficult it is to, you know, maintain tool face control with a motor, or how aggressive of a side cutting action you need on the bit for a rotary steerable curve. Certainly things are relatively simple if maintaining vertical, and there's not a lot of, you know, not a whole bunch of churn and debate on what to do there. You have depth cut control to manage torque fluctuations so that you can maintain, you know, the highest possible axial force without rattling everything to death. But yeah, certainly some compromises need to be made to drill a curve with the motor. You know, if you're talking about a Delaware curve, perhaps you have 25-degree back rakes in the cone with, you know, with an inch squared of rubbing so that you can get your 12 per 100 and land the curve on target. That's not going to be acceptable for, you know, for drilling the vertical section. Hopefully that kind of touches on.
Yeah, I think your point, Dustin, is that it's application specific in terms of your requirements from the bit, given your drive type, your well profile, you know, the length of the run, and these, you know, benchmark ROPs and these sort of things, right? So, you know, cutter durability concerns, lithologies. So I think I'll use that. Is that the only question, Jim, that I saw on the?
There was a question in the chat that Paul answered on the chat, but Paul, why don't you read that out to the folks that as well?
Okay, yeah, let me answer the bit profile question if I understand, because I'll answer that first real quick, and then I'll add. We don't make any distinction on the directional requirements in terms of the bit profile. Everything is a medium parabolic PDC today. I mean, there's variations in profile, but the amount of side cutting I need is going to be determined by the gauge pad length and the amount of gauge pad relief I have to the gauge trimmers. That is like the primary driver, period. So if, you know, there are subtle things. If you look at some of the work that, pair school of mine's, drawing a blank on the guy's name right now, but you know, they did work on profile effects. There are some profile effects, but they're way secondary to having a gauge pad that's 4 or 6 inches long and 2 inches wide touching the rock. If it's touching the rock, it's going to slow it down. If it's not touching the rock, it's got relief, it's going to cut sideways. So whether directional or not, we control that with the gauge pad design. It's length and it's relief. And most people don't talk about relief very much, by the way, which is really, really bad. So I can't steer with a 6-inch gauge. Well, did it have any relief or not? Would be the first question. So the other is directional wells. Almost always I'm sliding. I need to control the depth of cut. So I want to make sure all my tools will slide smoothly. And I want to make sure that I don't have a too aggressive of a drill bit, which is what Dustin talked about on depth of cut elements and all that. So, but the bit profile, yeah, they're all the same as far, well, they're not all the same. We do not use that as a selection criteria for directional bits. So how's that? And then Jim, you asked, or you wanted to talk about, somebody asked the question about what do we understand about HFTO or this high frequency vibrations that we see today. So there are 20 or 30 papers. If you type in HFTO, I wrote one in around 2007. Tommy Warren wrote one around 1998, and there's been 20 or 30, and they're proliferating really, really fast these days. So yes, we do understand where HFTO comes from, and I think we understand a little bit about how to fix it. But first and foremost, high frequency torsional oscillation, I rate that as anything 10 hertz and above. Some people say 50. I'm not going to quibble over that, but think of it as more like chatter, way faster than stick slip. It appears best if you read all the papers that have been written, I think you will come to the conclusion that it is driven by the cutting mechanics of cutting hard rock. So if you're drilling hard rock, the noise generated by the fluctuation in torque will drive you into this HFTO. The frequency is driven by the resonance frequencies of the BHA. So, but the amplitude is dependent on how hard the rock is and how fast you're turning it. So if I turn it slower, I get less HFTO. There was some work done by Baker that was published a few years ago that suggests there might even be a threshold there that it's nonlinear. So there's a linear portion where I double the RPM and I double the amplitude, but there's a point where it may just back off. So I don't know. I think the jury's out on that one for sure. But there's a lot of work being done in that area right now. It probably, I believe, is the root cause of most rotary steerable failures. Motors themselves act as an isolator, and so everything above the motor gets isolated. The motor takes it in the shorts. That's the bad news for the poor motor, but everything above the motor is probably isolated. But if you're running a rotary steerable, all that rotary steerable and MWD is exposed to it as well. So anyway, my goodness, there's lots of papers, and they're added to every single day. So can you see HFTO from the surface? No. It's downhole 50 hertz to 600 hertz. I have detected 30 hertz data in a vertical well. I've detected 30 hertz oscillations on a rig. So I won't say never ever, but no, it's going to be isolated downhole. You won't really see it up home. So. And we're not sampling anywhere near fast enough. You need to be sampling 1,000 hertz plus if you're going to really see what's going on.
Thank you, gentlemen. So The next question I have is there an appetite for, in the spirit of knowledge sharing, is there an appetite for, say, application specific discussions to, get into the detail of one application, whether it's, Dustin mentioned the Haynesville, of course, the Permian's definitely a big one, at least in U.S. land, or any other one, right? So there's specific applications in each, basin. There's Haynesville's got, 17 and a half, 12 and a quarter, 9 and 7/8, some 8 and 3/4, 6 and 3/4. Permian's got, well, pretty much every bit size available on the planet goes into the Permian at some point. So is there an appetite for having some discussions around specific applications so we can, kind of see where the rubber meets the road, and really get into some of these topics on a level that we can really cross share instead of talking in generalities?
I would tend not to do that. My guys that drill wells compete with other people that drill wells, and even though we always work through vendors, cutter vendors, bit vendors, and yes, there's always, I'm going to call it leakage of knowledge, and I'm okay with that. I mean, that's kind of what the industry, that's what SPE and IDD and everybody's about, is to share best practices. But I would rather pick up and learn what my specific things are on a two-way or three-way conversation. And the two-way would be our field crew, our technical crew, the bit vendors technical crew, and the cutter vendors technical crew. So that's kind of a four-way conversation around, let's solve this problem and let's figure it out. And as opposed to, let's say, an industry discussion on drilling in the Permian. If you have one, I may get in because I may want to hear what you guys have to say, but I'm not probably going to tell you everything that I think.
I mean, I think it's one thing to have a discussion about the particular area. You can reference Fred's paper on Delaware intermediate drilling from last year. I think it's an entirely different subject to start talking about cutter grades and maybe even specific layouts, what you're doing in that space for a particular application. There is a bit of, I can guarantee you that most of the smart people will likely end up with a somewhat comparable solution, but at the same time, there needs to be, or there's perceived to be some competitive advantage, as to keeping some of that, in-house. Obviously with the understanding that if there's another operator drilling the same hole size, that design is probably going to get pitched if successful to them. But maybe they won't know why it's successful and be able to iterate on it. Whereas we will have the inner workings of that product, be able to iterate on it, and then make the next step after that. And they'll just kind of be one or two steps behind every product cycle.
Yeah. Yep. Okay, so fair enough. Is there then an appetite to give, I'll say, any vendor out there, whether it would be, sensor, that there's been some stuff about sensors lately, there's been some stuff about cutters lately, giving the bit vendors a specific kind of, normally the sales guys will end up selling, sending out all the performance bulletins to, the respective operators to try to sell their bit. I think, is there an appetite for having them showcase kind of a case study? I think we've done it a couple of times before, maybe, right? Just kind of revisiting that. I'm not saying monthly or anything, but on some more consistent quarterly or something like that basis, just to kind of circle the wagons and say, hey, here's our newest, you guys mostly aware of the cutter technologies and, design performance and things like that. So showcasing new technologies from the bit side then.
Yeah, my feeling is, in fact, when you said case studies, so you need to join if you're not on the IDC forensics code rewrite. We're upgrading the dull code system for IDC, and one of the subjects we have there is case studies. The idea is, I'm going to call it the equivalent of the Harvard Business Review case study, where you say, here's all of the things that happened on this particular run, or here's my diagnosis. Here's all the relevant data that I can gather, so that we can all agree to understand kind of how that analysis was done and what the conclusions were. If you can do that in a case study, man, I'm all in. But don't give me a case study that shows me the overall ROP and the overall life, and then say it's my new cutter that did X.
Yeah, I was going to say the same thing.
Yeah, you need to dig into the details, and whoever gives that talk better know. When I ask them about Brandon's cutters here, they need to say, yeah, this is the one that's tangentially 25% tangentially tougher than the one, and here was the old failure, and here's how the new failure did, and all that. So, man, I'm all about details. If you want a case study, it needs to be Harvard Business Review kind of quality of the level of data. So
don't throw three bar graphs up on a page and say 300% improvement due to next line, new product development. Like that's, and then not understand the variables as to what went into that change. I think one of the biggest wastes of time is us squabbling with each other as to what the reason is for the improvement. And then debating on whether that application is analogous to what we're doing. I mean, that's just a complete waste of time. If you don't come prepared to be able to answer those tough questions, then my other pet peeve is not looking at the dulls at all and just giving a run summary of the total footage drilled and the ROP. Obviously I'm going to be pretty skeptical of, something that's coming out, with a core out 9 times out of 10, but is eking out 10% performance based on, in the baseline. So yeah, have the dulls, good dulls, not rigged dulls with mud all over them. Get with the repair shop, do an analysis, come with the geographic extent, a rock strength analysis, everything you can to say that this is analogous and worth your time to look at and is an adequate offset.
So it sounds like you guys are already doing that in your grading thing. So, it may not be worth repeating here because I don't want to double the effort.
Well, I mean, there's a whole work group working this. This will go on for the whole year plus of trying to upgrade how we do things like this. But I mean, I think it's a worthy effort without a doubt. And Dustin, I know, Matt Bowes and several. But if you're not on that, you're welcome to join. I would say something else too is, if you when we talk about looking at dulls, if you have one run and you which is in a lot of cases, and I'm sure you might only have one run, and then you need to make a design change, and you make the the change. That's where we typically rely on your ability to model and know what the stresses are within the cutters. If you're modeling for CFD, to know that, hey, if I change this nozzle, it's going to improve the cleaning of the bit or whatever. If you're running in a place like West Texas or Delaware or Midland or something where you have 50 rigs running and you've got 100 dulls, man, you can just line up all the dulls of one part number and you say, look at cutter 27 right here. I see that weakness that shows up on every time that gets broken. Well, that's a design change that I made, and here's what I did. And so you can have a different kind of approach based on whether it's statistical analysis or whether it's a unique one-ofs. You need more modeling capabilities. Statistically, you can do that as long as I'm willing to run them or somebody's willing to run them. I mean, again, if all runs are pretty good, hey, I'm willing to try and do things. That's okay. If you're just guessing in the dark, boy, I don't have a lot of time for that. And offshore, I have no time for that ever. I want the very first one to TD the well from the beginning. So I want a lot more design, modeling, confirmation, testing, lab testing, everything in those rigs that cost me $3 or $4 million to make a trip versus a land US, something like that. So.
I do agree, Paul. I do think looking at dulls and analyzing dulls is something that is kind of getting lost more than it used to. And I'm glad to see the industry, the big companies, and even the cutter companies now make some investments into automating those and taking the grading off of a percentage of the bit and looking at individual cutters, and then being able to look at a massive data set to see where those trends are. So.
Yeah, I think without a doubt. I mean, the industry's been moving that way already. I think we're just catching the IDC code effort up to what's been going on by bit companies and cutter companies for a ways now. So, but yeah, that is a really big deal. I think that's going to be great fun.
All right. Jim, that's all I had, unless you've got any more comments, thoughts.
We've covered a lot of this area, and some of these potential educational, informational classes. I know Paul is doing a lot of this stuff. I think it would be good to have a cohesive educational effort, though. In other words, if there is sort of a standard, to me, it ties in a little bit with the dull grading and so forth, that we're all singing off the same hymn sheet when it comes down to it. So I think those are good. And then Paul, we have a couple minutes. You had referred to the IDC thing or the initiative that's going on upgrading the grading. And did you want to take a minute or two to maybe elaborate on that just a little bit?
Yeah, you bet. So in fact, our kickoff meeting for over 100 volunteers on this project, Dustin Deschelle, myself, Jim, Robin McMillan, and Robert Van Coolenberg are kicking off a upgrade of the IDC dull codes. So the recognition is, one is that if you have 2 or 3 people looking at one drill bit, they can come up with 4 or 5 codes, just depending on how they feel that day and all that. And part of it is, it's just ambiguous. It's not even that it's poor training. I think there's some ambiguity there that we want to get rid of. Secondly, the codes were written 25 something years ago. Guess what? A lot of things have changed. Brandon talked about, what we understand about cutters and the way that they're run and the way we run bits is dramatically different today. So that's second. Third, the codes before used to focus on drill bits alone. When I joined ExxonMobil, we were not taking pictures of stabilizers. I require stabilizer pictures all the time because they tell me a lot about the quality of the wellbore. And if I have dysfunctions like spiraling, it'll show up as wear patterns on the BHA somewhere. So anyway, we're trying to upgrade that. We have work groups planned for drill bit and cutter technology codes. We have a work group on the BHA and motors, and somebody asked a question about motor failures and all that. So we got one on motors. We have a third work group on case studies. Give me all of the data that you use to make a decision, and we'll get the subject matter experts to agree and say, here's our analysis of these, hopefully a few hundred case studies that we pull together as a requirement. So. I have been authorized to give to share ExxonMobil's. I give a training class on forensics, and I've been authorized to share that to that work group, and then ultimately to the industry at large. So there's an effort there that you can hear at least what Exxon thinks about a lot of forensics work anyway, if you're interested. And again, I suspect all of these work groups are going to way outstrip that. We'll get. With 100 really smart people, will go way beyond what we're doing today. That's probably the biggest thing I want to say about upgrading that. It'll be a year-long effort. I'm hoping that we get something pretty well finalized by the end of 2021, and that we get to move forward. I want to say one other thing, Jim, and you asked about, like training for drill bits and all that stuff. You guys, I think almost everybody on here, certainly everybody on the panel has seen ExxonMobil's bit selection guidelines at one point or another. We, just like we have a stabilizer selection guidelines, I have a set of internal guidelines on drill bits as well. Don't do this, don't do this. And we're pretty picky on several things. I have not been authorized yet to share that widely, even though every drill bit vendor has it. They have to. I mean, it's like, hey, I need you to build me a drill bit, and they say, sure, what do you need? And like, what size? And I go, oh, I can't tell you that. It's secret. It's like I have to tell you. I have to share with vendors and cutter vendors as well what we think and the way we think. So we've done that. We just have not published it yet. I continue to work on management, and because I think ultimately it's what we will wind up doing. It's not terribly secret. I've even had at least 2 bit vendors that have said product line X follows your guidelines 100%. The only thing that would be different would be in the gauge pad, because Exxon typically wants long gauge with a small amount of relief, and some other operators don't want that. So the nice thing is, you know what? I'm great if that vendor says our new product line X is going to follow your guidelines, then I don't have to go in and double check everything on every single line to look through it when we do a design review. So anyway, Jim, I think probably 2022 or maybe 23. I bet I can convince them to allow us to publish it, but it won't be 2021. I've already tried so far. So.
Well, we'll keep pushing on them anyway, right?
Yeah, and and I understand. I mean, I didn't know what their concerns are, but just like on stabilizers, we don't make stabilizers, and so we want stabilizers to be readily available that meet our criteria. I don't think there's been a lot of pushback of other people saying, no, I want a different requirement than what Exxon has. They've been reasonably well adopted in the industry. And I suspect if you look at the bit selection guidelines, most of them are pretty common as well. I don't think there's nothing really radical, except for our gauge length, maybe. That's the one that, a few guys like shorter gauge. Hey, that's okay.
Andrew, I see that Stephen has joined us. Stephen, do you have any last minute comments here that we can use for a wrap up?
Yeah, I guess I'll go ahead and introduce Stephen. So Stephen is with ConocoPhillips. Stephen, if you want to, go ahead and weigh in here. We've covered a few topics. I know you have the outline, but feel free to weigh in with your thoughts. And thank you for joining.
Yeah, no, apologies firstly for being late. We just had a reorg and it's something came up. But and secondly, apologies. I just getting to know Zoom, so I was talking with the mute on. But yeah, thanks for having me. Apologies for being late. I'm a drilling engineer over at ConocoPhillips, working in the analytics department now. So I'm happy to work with you guys. Further, I got nothing to add just now, but it's been some interesting conversations. But I can chip in as and when needed. And apologies for being late.
No worries. Jim, correct me if I'm wrong. This will be all recorded and on YouTube at some point. So.
That is correct. Yep. Probably within about 5-10 minutes after we're done, the recording will be launched live, so you can go back and take a look at it.
Okay.
I do.
If we don't have anything else, anybody else have any comments? Last minute words?
I was just looking at the notes that I sent to you, Jim, in terms of questions, and I do have one comment. We'll see if anybody's got any energy around this one. The one thing that I have a real difficult time in doing is comparing 4 or 5 bit vendors in terms of aggressiveness. I'm running a bit in the ground, and I've got 3 on the rig from different vendors, and I'm having severe stick slip, and I need one that's less aggressive. Now, again, if I have a super detailed sheet filled out by Exxon for the ExxonMobil checklist, I can have a reasonable good idea about if it's more or less aggressive. But anybody have any energy or interest in developing a cutting mechanics, code that says, here, I'm going to run a open source code that the vendors don't have to give away their secret sauce. They run the code, they run that code on their drill bit and say its weight and torque ratio is X, or its and its efficiency is Y on that code. And then everybody runs the same code. If you change the back brake or you change the chamfer, those kind of things would show up. So interest from bit companies in doing that, interest from operators or anybody else.
I'd be a little bit skeptical on the code to be able to handle different shapes, but I think overall it's a fantastic idea if people would be willing to take that on. Yeah, I certainly know there'd be a variety of circumstances where we could use a vendor agnostic tool like that to compare multiple designs.
Yeah, the new shaped cutters, that's probably a tough one. That makes things harder because then the code has to have a lot of detail in it. And yeah,
I mean, especially at downhole pressures, like that's just.
But if you get to depth of cut limitations as well, it'll change that torque ratio, right, or whatever it is that the number is.
Yeah, well, the good thing is I'm going to compare two bits, and I'm going to make the same pore pressure prediction or assumption in both cases. So at least I'm getting a bit-to-bit comparison, if you will. The problem that I have is if I run one vendor's code and their results, and I run another vendor's code and their results, first off, they're not even using the same rock and assumptions.
Yeah,
it could be off by 50%, and it just doesn't mean much. So, and again, I have a way around it today, but it'd sure be nice if I had a open source tool that everybody could run against, if you will. Just a thought.
Yeah, I mean, our way around it is inferring from back rake distribution shape, cutter count.
Yep.
That's a kind of subjective strategy.
Or calling and talking to the field rep or the engineer about the designs on location.
Well, no, I can do that. I always get that information. So I get vendor A's rep and vendor B's rep and vendor C's rep, but vendor C doesn't know anything about A and B. And I'm trying to decide. I've got a bit in the ground and I've got one that I want to on the deck, and I want to pick one of those. And so the vendor reps can't help me other than to understand their own.
Well, you're assuming that, I guess that would require a common understanding of how to design bits from, which doesn't,
If the model accounted for back rake, chamfers, polish, and depth of cut elements, those are the big keys. Dustin just brought up the new shaped cutters, whether they be 3D shapes on the front first face, and then of course the chisel shapes and all that. If there's an efficiency gain or something there to be had, that adds more than than most people will probably be willing to bargain for. But it would sure be nice to have a tool that I could run and evaluate. And again, I'm way beyond running red bits versus blue bits versus green bits and yellow bits. I want design details. I need to tweak that back rake from 25 to 27 degree back rake for the following reason. That's the kind of stuff that we're doing these days. So.
Yeah. Well, that could be something we could take a look at, Paul. I mean, that would have to be a joint industry project to get that pulled together, because you need feedback from the manufacturers all the way through to the end, including rock strengths and so forth. So I could see it being doable. I don't know how big a project that would be, but we could certainly have a look at that, have a chat. Do you think that would be worthwhile, Andrew?
I think some vendors, capabilities are beyond that of others, and by kind of either remediating some of them or bringing some of them up, you do some disservice and you do others a service. So
right.
there's a lot of moving parts to the whole thing. I think it's a noble effort for sure.
Yeah. Okay. We'll take that as a takeaway then.
Okay. Wonderful. Thank you everybody for your time and participation and discussions. Yeah, we'll look forward to having more of these and kind of getting into more detail on some of them, but in the future. But appreciate y'all's thoughts on kind of what our outline is currently, and we'll make the changes accordingly and make it more pertinent here. That's all I got.
All right. Thanks, everybody. As Andrew indicated, this will be up on YouTube here shortly. So appreciate the participation in the discussion. And we're looking at doing this as the first of a series of things that we'll do throughout the year. So I think, Paul, we could probably track some of the IDC activities and include that as we go forward. I think keeping everybody updated and all those types of things would be good to have. So again, thanks everybody, and we'll talk to you soon. Stay safe.
Yep, everybody.
Hey, guys.